Zeal Education Society, redefining excellence.
Hello students, I am Dr. Mahadev Unde, going to deliver the lecture on Basic Electrical Engineering. In a previous video lecture, we have learned the AC fundamentals, in which we have studied the RMS value, average value, form factor, crest factor or a peak factor. Then we have also studied the phase difference, in phase lag and phase lead. So in this video lecture, we are going to learn the AC series circuit, in which the first part is alternating current through pure resistance, AC through pure resistance capital R. Now the diagram is like this. The supply voltage small v equal to V max sin omega t. Now as circuit contains only the resistance, whole supply voltage will be dropped across the resistance. So this is VR, voltage drop across resistance. Let small v equal to V max sin omega t, equation 1, is the supply voltage. Small I, instantaneous value of current. Instantaneous value of current. And small Vr equal to I into R equal to voltage drop across resistance R. Now, as whole of the voltage supplied drops across the resistance, we can write small Vr equal to I into R equal to V max sin omega t. And therefore, small I equal to V max upon R sin omega t. I equal to I max sin omega t. So this is the expression for current. This is equation 2. Now we have to consider, we have obtained the expression for current. Say this is part A, B part is waveform. Now when you comparing equation 1 and equation 2, these are the exactly similar quantities. There is no phase difference. Both are the reference quantities, and therefore we can draw it like this. This is t-axis or omega t or theta. Now this is origin. Say this is voltage. Say, and current is also in the same phase. Now here, both the voltage and current achieve their minimum, maximum, and minimum values at the same time, and therefore they are said to be in the same phase. So both voltage and current are in the same phase. We can say in phase. So they are in the same phase. Now the C part is phasor diagram. Already we have studied that the phasors are always represented by RMS values, and here both the quantities are reference, and therefore say this is phi, capital V, because the phasors are always represented by capital letters, and this is I. And actually, strictly speaking, it should be one above the other. There is no phase difference, there is no phase angle between voltage and current. D power factor equal to cos phi, where phi is the angle between voltage and current. Therefore, phi equal to 0, and hence power factor PF equal to cos phi equal to cos 0 equal to 1 unity. So the power factor is unity. Now the power P in AC circuit, P equal to phi I cos phi. Where cos phi is the power factor, and P equal to phi I in DC circuit. Now expression for power. Expression for power. The instantaneous power, small p equal to product of voltage and current. So instantaneous voltage into instantaneous current. So that is equal to phi max I max sin omega t square. This can be written as phi max I max 1 minus cos 2 omega 2 t divided by 2. So phi max I max upon 2 minus phi max I max upon 2 into cos 2 omega t. Now this is part 1 and this is part 2. The first part is fixed. It does not vary with the time. There is no time quantity. Whereas in second part, it has a double the frequency, twice omega t. As compared to voltage and current, it has a single sin t. Here it is twice omega t. And second part is pulsating. This is fixed. And this one is pulsating. Pulsating means varying with the time factor t, and its value over a complete cycle equal to 0. And therefore P equal to phi max I max upon root 2 upon root 2. So P equal to phi RMS I RMS, and therefore P equal to phi into I. This is the watt. Average power consumed. In practice, it is P equal to phi I cos phi. but cos phi equal to 1 in this case. And therefore P equal to phi I, and phi is nothing but IR into I. So P equal to I square R equal to phi I. So this is what equation 3. So this is the expression for power. P equal to phi I equal to I square R. So the power consumed is I square R, or you can say phi I. But for AC circuit, power is always phi I cos phi. Now I have a waveform for this. Here it is, both voltage quantity and current quantity, both are positive, and therefore their product is also positive. Now in this band, both current and voltage are negative, and therefore their product is positive. This is P equal to phi max I max sin square omega t. But average power, the average power is somewhat here. So P equal to phi I. P equal to phi I or phi I cos phi. Now here in both the half cycles, power is positive. Power is positive, and therefore whenever alternating current flows through the pure resistance, it consumes the power, and that is given by P equal to phi I cos phi. But as power factor is 1, the power equal to phi I equal to I square watt. So in this way, we have finished this part. We will stop here. Thank you.